Hi everyone. In this video I'm going to show you how you can scale out your app services, and we're also going to take a look at auto scaling feature of app services. So if I go to scale out right away, I can see that I have two options: manual scaling and custom auto scaling. That's because I'm under S1 tier, which is a production tier. With S1 you get auto scaling. If you are under one of the dev test tiers, you won't get auto scaling at all, but you are going to get manual scaling if you move to B1. What is the difference though? But before continuing with that, I would like to talk a little bit about the difference between a scale up and a scale out, just to refresh your memory, because we did talk about a scale up feature of app services in one of the previous videos, and I showed you how you can scale up or down your app service. Imagine you have a web server, a virtual machine with a dual-core CPU and 16 gigabytes of RAM. When you scale up, you're basically adding more resources. You're going for a bigger server. So imagine that you scale up and you move to a virtual machine that has a quad-core CPU and 64 gigabytes of RAM. That's called a scaling up. When you scale out, you actually add more instances instead of adding resources to your existing server. You add more instances of that server. These instances are often identical to your one or your original instance, and then on top of that you use a load balancer to distribute the load evenly among your additional instances that you have created. So that is the difference between a scaling up and a scaling out. Now, manual scaling and auto scaling. Manual scaling is when you decide to have a fixed number of instances at all time. Imagine that you know how much traffic you receive and you decide that you need 3 instances at all time, no matter what. You do not need to add more instances, and if you go for a lower number, let's say 2 instances, you're gonna face performance issues. So you know for sure that always at all time you need 3 instances up and running. What Azure does for you is that it makes sure that you always have 3 instances available. Let's say if something goes wrong in one of the instances, if a hardware failure happens, then it's going to automatically create another instance, and it will always maintain 3 instances online and available for you. Auto scaling is different. Auto scaling is the process of dynamically allocating resources to match the performance requirements. And it's usually based on some metrics and some rules. To start, let's just configure manual scaling. I'm going to say I require 3 instances at all time, and then I'm going to show you how it's going to change. So it actually shows up here. It says, let's go back again for a second, move to 1. So the default configuration is manual scaling and 1 instance. And let's go to overview. And here you can see that it says S1 1. It means we are under S1 tier and we have only 1 instance up and running. Now if I go here again and change it to 3 and save, you'll notice that the number will change to 3 because I have 3 instances. Now, something to have in mind is that if we scale out, we're going to pay this amount for each one of the instances. It doesn't mean that we are still going to pay 93.44 Canadian dollars every month. We're going to pay 93.44 multiply 3 because we have 3 instances up and running. Just watch out for the cost. In the previous video, we also added a Application Insights. So if you go to your Application Insight and go to Live Metrics, you will be able to see some information about how your users are using your application. Right now it's not showing anything because I have no traffic. But I have Postman, and if I try to use my web API, try to send requests to my web API, Application Insights is going to pick up those metrics and it's going to show them to me. Not always it reflects as fast as you would like to when you change the configuration and scale out your application, but sometimes it does show the number of instances that you have online, and that's what I'm trying to do here. It's going to take a little while because my application kind of went to sleep, but now it worked. And as you can see here, Application Insights has started to work and show me some metrics. Before continuing, I would like to talk about our sample project. So in the sample project that we have, which is hosted on GitHub and you can download it at any time, there's a project called the Web API. In that project, I have a controller called LoadTest, and that's the class here. So in this controller, I have only one get method. The purpose of this get method is to basically consume all the CPU power of your virtual machine or your server. What it does is that for 5 seconds, it creates multiple threads, and each one of those threads tries to maximize the CPU usage. So basically what I'm trying here is maximizing the CPU usage of the server, because I'm going to configure auto scaling and I'm going to configure it based on CPU usage. And I'm using Postman to test my web API. Postman is a collaboration platform for API development where you can manually or automatically, when you're using the runner feature, send requests to your web API and see the result. I have a collection here with only one request, which is a GET request, created. I have created 2 environments. One is called Azure, one is called local. In these environments, I have only one variable called base URL. I'm going to share the collection with you, so if you want to follow along and play with it, you can just go there and update this value for the variable and play with it. So I have Azure, and then I have local. Again, just the base URL is there. So if I choose Azure and then click on send, it will send the request to the endpoint I was just talking about. What happens is that the CPU usage goes high, as you can see here. And as I mentioned earlier, Application Insights doesn't really do a great job with showing the available servers, online servers, but in reality I have 3 instances up and running. If I go back here, you can see that I have 3 instances, and I'm actually getting charged for the 3 instances that I have up and running. I also, in the Postman, have created a test. It's a simple test. It only checks to see if the returned status code is 200. And if it is 200, then my test is passed. So, with all that being said, I'm going to go back to my app service, and I'm going to configure auto scaling for it this time. Before I continue with that, I would like to mention that auto scaling is actually not a feature of app services. It is a feature of Azure Monitor, and it also applies to Azure Virtual Machine Scale Sets, Service Fabrics, as well as Azure Cloud Services. If you go to Azure Monitor, you can see that the option is right here under Settings, Auto Scale. If you click on it, you'll be able to see all the auto scaling features that you have configured. I have two, one of them is not really in use. This one is the one we're using. You can see that it says the location is East US, instance count is 3, and auto scaling is disabled because I'm using manual scaling. Now if I go back here and click on auto scaling, we will be able to configure auto scaling for our application. And the way it works is that you either, again here you have the option to say maintain a fixed number of instances, which is same basically as the manual scaling. Also you have the option to say a scale based on a metric, and this is the interesting one. I've already created a rule for it when I was testing for myself, so I'm just gonna go and quickly delete the rules because we want to create them from scratch together. So scale based on a metric, what does it mean? As I said earlier, auto scaling means automatically and dynamically allocate resources to match performance requirements. And the way it works is that you create some rules for it. And the rules are based on some default metrics that you can get from your app service instance. So if I click on add rule here, you can see that under metric namespace, I only have app service plan because I'm configuring the auto scaling for my app service plan. And again, yes, it is at the app service plan level as it states here. So if you configure scaling out, because it is at the app service plan level, it's going to be applied to all the app services you're hosting under that plan. Have that in mind. And then you have a whole bunch of metrics you can choose from. CPU percentage and memory percentage are the two most popular metrics that are being used for this purpose. I am going to use CPU percentage. Basically, I'm telling app services to monitor the CPU percentage, and then I'm going to define some rules for it. So based on my rules, it's going to dynamically add or remove resources, add or remove servers. So let's move forward and configure our auto scaling. Under time aggregation, I'm going to use maximum. As it says here, time aggregation is being used when we are actually aggregating the sample data. So if we say average is going to get the average of the sample data, but I'm going to use maximum because I want this to happen as soon as possible because I want to show it to you. I'm going to say CPU percentage. Here under dimension name you can add or remove instances. Right now I'm going to say read the metric from all the instances. And then under operator, we can choose how we want to create a rule. I'm going to say greater than and then 70%. Let's make it 75%. Basically what it says is that whenever the maximum CPU usage went over 75% for the duration, I'm going to make it 2 minutes. Under time grain statistic, I'm also going to use maximum. And as it says here, if we select, for example, average, and then the time grain is 1 minute, which is here 1 minute, it means that the metrics will be aggregated every 1 minute by taking the average, but I want to take the maximum again here. Do what? Let's define the action. Increase count by 1 instance, and cooldown basically means number of minutes to wait before adding another instance. I'm going to say add 1 minute actually after adding another instance. So again, this rule here says whenever the maximum CPU usage of my old instances I have goes over 75% and stays there for the duration of 2 minutes, I'm going to add another instance. So that's our scale out rule. I'm going to also add a rule to scale down. I'm going to say whenever the maximum CPU usage of all the instances goes under, let's say, 50% for the duration of, again, 2 minutes. Again, I'm going to select maximum here. This time, decrease count by 1 instance, and then 1 minute again for the cooldown period. So scale out, scale in. Here, under instance limits, we get to define a minimum, which is obvious. I'm gonna say I want at least 1 instance. Maximum, to just create a limit for it so it doesn't go crazy and create 20 instances for us. And then a default. This default here is I'm gonna make it 1. Basically, you define a number here, and Azure uses this number to scale out your app service to a default number when it cannot read the metrics. So here in our auto scaling rule, we selected maximum CPU usage. If for any reason Microsoft Azure can't use that metric, meaning cannot read the CPU usage of your instances, it's going to use the default value, and it's going to maintain the number of instances that you have created here, if you put here actually. If I say, if you couldn't read the metrics, just create 3 instances for me and keep it there. That's what is going to happen. So I'm gonna just put 1 here and save it. Now that I have saved the auto scaling and I have configured auto scaling, here you can see that we have 3 instances. But if we give it enough time, meaning a few minutes, because we are not really using it and the CPU usage is below 50%, it is going to start removing the instances for me, and the number of online instances for me is going to go down to 1. So I'm going to wait for it to happen, and then I'm gonna, as I explained, use Postman to send requests to my web API, which is going to try to max out the CPU, and then we're going to take a look at it, the metrics, and we're going to see how app services is going to scale up based on the CPU usage. So the number of instances went down to 2, and if you wait a few minutes, another few minutes, here we go. It is now 1 instance. Now we're going to use Postman, and to be specific, we're going to use the runner feature of Postman to send multiple requests to our app service and see how it's going to react to that. So the runner feature, or the collection runner feature of Postman, allows you to send any number of requests basically to an endpoint. I'm gonna say send 300 requests, and between each one of them wait for half a second. This is the request, the GET request I have, and then I have chosen the Azure as my environment. Let's start. Now if I go back to Application Insight, I will be able to see that the CPU usage is really high. So we're going to wait for, let's say, 5 minutes, and I'm going to fast forward the video during this 5 minutes, and then we're going to periodically take a look at the Azure monitor, and we're going to refresh this page to see how many instances we have. Right now we have 1, and I really expect that after 2 minutes Azure starts to add instances. So we saw how app services dynamically added and removed instances based on the rules we defined for it under autoscaling. Something else I would like to mention is that we can actually add as many autoscaling or scale condition as we want. Another cool feature of it is that you can specify start or end dates. You can also specify repeated specific days. For example, some businesses experience more load and more traffic during the weekends. You can simply this way say that on Saturdays and on Sundays, starting from this time and ending this time, I want to have my rules in effect. That's another way of configuring auto-scaling for your app services. So right now I have 5 instances up and running. I have stopped my runner, so gradually the number will go down. After about 5 minutes, I'm gonna go back to the one instance that I defined as the minimum instances when I was configuring auto-scaling. So basically that was it. Hope you learned something new today.